Good afternoon. Thank you for joining us at our first ASHRAE Iowa chapter meeting of the 2020-2021 Society year. I'm Chapter President Adam Pulse, and on behalf of the Iowa chapter, I want to extend a warm welcome to our members and especially to any non-chapter members who have taken the time to join us for our presentation today. Founded in 1894, ASHRAE is a global professional society committed to serve humanity by advancing the arts and sciences of heating, ventilation, air conditioning, refrigeration, and their allied fields. As an industry leader in research, standards writing, publishing, certification, and continuing education, ASHRAE and its members are dedicated to promoting a healthy and sustainable built environment for all. With this in mind, and given the current uncertainty with returning students and staff safely to schools, ASHRAE has created a COVID-19 Epidemic Task Force dedicated to the reopening of schools and universities. Today's presentation focuses on K-12 reopening strategies and is presented by Iowa Chapter and Schools Task Force Team Lead, Corey Metzger. Corey Metzger is the founding principal of Resource Consulting Engineers, LLC, based in Ames, Iowa. He's an active in ASHRAE as the team lead for the Epidemic Task Force Schools team, chair of the Conferences and Expositions Committee, and member of Technical Committee 9.7 Educational Facilities. His background includes completing design and analysis for HVAC systems for multiple building types, including K-12 schools, higher education, healthcare, commercial, and industrial facilities. Once again, I'd like to thank you for joining us, and we'll turn it over to Corey.
Great. Thank you, Adam. Very much appreciated. I appreciate the opportunity to be here. We'll do my best to cover this information. It's obviously critically important right now, given a lot of uncertainty that exists and all of the things that are trying to be accomplished. So want to be very serious about that. I hope we can have a little fun too along the way. I'll try to make you laugh once or twice if I can. I won't be able to hear that. Hopefully you can bear with me. Just briefly, learning objectives. The goal is to get through basics of the SARS-CoV-2 virus and some transmission pathways. Talk about the schools team guidance document for reopening facilities that we've produced and is available to anyone. Understand more specifics about the recommended strategies that are in that document and why those are there, along with some potential considerations to look out for if considering implementing those strategies. And then to look at, just briefly, some potential changes that could come down the road after the pandemic is passed, hopefully. Just briefly, would like to make a number of acknowledgements. So the Epidemic Task Force is led by Bill Bonfleth. He is doing an incredible amount of work as part of that group and in that position. Dennis Knight is the vice chair of that group. Conlon is leading the building readiness group, which kind of is an overarching focus for buildings in general. I'd also like to acknowledge Rick Hermans, who I think might be in attendance today. He actually was the schools team lead from the inception of the schools team on the Epidemic Task Force. I had the privilege to take over from Rick after he had a chance to move over and is now leading the research team. There are a number of other teams working on how to safely occupy buildings at this time and to do what we can for, I apologize, do what we can for improving the built environment and its impacts on building occupants, given the challenges that we're facing. Technical Committee 5.5 has some good information out on air-to-air energy recovery that we'll briefly touch on and I may discuss later if we have time. And then just wanted to acknowledge we've got an image that I'll mention later in the session here. So key things to cover to start off. I want to go through what we know. There is an enormous amount of information out there right now. Some of it's very good information. Some of it's not very good information. Some of it we don't know if it's good information or not yet. So we're working on understanding that. The thing I'd like to suggest to you is you consider your source. So seeing me today, you'll notice I unfortunately had to trim my quarantine beard, but this was less than a week ago. So again, feel free to disregard anything I say if it doesn't make sense. On a more serious note, and keeping in mind that I do want you to focus on what we know and what we don't know. I'm sure you've all seen dozens or hundreds of images of the virus. So the severe acute respiratory syndrome coronavirus 2 or SARS-CoV-2 virus is what we're talking about. It's related to SARS. It's an enveloped virus, meaning it's got a lipid envelope around the RNA. The diameter of this virus is approximately 0.12 microns. It can survive in air for hours and for days on surfaces. So those are all key things we need to consider as we're this information. So this is the image I mentioned on the acknowledgement slide, but it gives you an idea of the size of these viral particles when they're on. Likely not floating in air just independently, but you can see how small they are and what a challenge it might be to deal with them. So more of what we know. There's a lot of research being published right now. I think it's safe to say that the pace and the process of this research is significantly accelerated beyond what would normally be the case given the urgency of what we're trying to deal with. So this isn't, I guess, a normal time for a lot of things. We'll talk about that. But just looking at, this is a very small sample of references that might be useful or important in looking at K-12 school reopening. But key thing to remember is if you look at a number of these documents, you will see that, for example, this document and this document may entirely contradict one another. So the information that we've got right now, while being developed in, I think, with the best intentions, has limitations, especially as we talk about schools. Understanding any takeaway from a school-related study needs to be considered given the fact that many schools haven't been in session at all, or if they have, may have been in session with significantly reduced numbers of occupants. Some other key information. As you look around and listen to the news and read information from CDC or WHO or many others, the focus has been consistently on social distancing, cleaning of surfaces, and PPE. And those are not things that I'm suggesting we shouldn't be focused on, but I think you will see that until recently, there have been a significant lack of discussion about airborne transmission of the virus. And when I say airborne transmission of the virus, I don't mean short distance transmission between two close contacts. We're talking viral particles that have entered the air and crossed a room or potentially gone further than that. So I'm not sure if you're aware of this or not, but in early July, there was a letter from 239 scientists to the WHO identifying that this needed to be, the airborne transmission needed to be considered. There are a number of ASHRAE experts. Bill Bonfleth was one of the, I think, the key authors or assisted significantly authoring of that document. So there are a couple of cases that I suspect many of you have heard about. One is the Washington State Church choir rehearsal. They had a 2.5-hour practice with 61 people in attendance. There was one index case. From that one index case in that 2.5-hour period, there were 33 confirmed cases and 20 probable cases. So almost 87% of attendees were infected. There were 2 deaths that resulted from that case, but the important consideration there is that it's likely that that one index case did not have close contact with all of the 53 suspected cases that came out of that. And there's the Guangzhou, and I hope I've pronounced that correctly, China restaurant. case, and we'll talk about that more on the next slide in a little more detail, but there was one index case, there were 9 additional cases. So in looking at that particular case, that is one where there was consideration given to the mechanical system. So the restaurant was poorly ventilated, but had units that circulated air, as you can see, generally arranged to each cover a portion of the restaurant area and recirculate. And found from that case is that the index case was at this table in the center here. Without looking at the mechanical system, there may have been an assumption that this table would have been as likely to have infections as these other tables, but the majority of the infections occurred in this area that was covered by the one unit. So all information to keep in mind as we think about airborne transmission. Another important piece of information to have in mind here, there are 2 key statements that ASHRAE has made in a position document. One being transmission of SARS-CoV-2 through the air is sufficiently likely that airborne exposure to the virus should be controlled. Changes to building operations, including the operating of heating, ventilating, and air conditioning systems, can reduce airborne exposures. And the second statement, ventilation and filtration provided by heating, ventilating, and air conditioning systems can reduce the airborne concentration of SARS-CoV-2 and thus the risk of transmission through the air. Unconditioned spaces can cause thermal stress to people and may be directly life-threatening, and that may also lower resistance to infection. In general, disabling of heating, ventilating, and air conditioning systems is not a recommended measure to reduce the transmission of the virus. So I wanted everyone to have those 2 statements in mind. That's from the position document on infectious aerosols, which was approved by the board of directors of ASHRAE on April 14th. So a little more of what we know. We know that it is likely that the majority of cases are still being transmitted via close contact. So that doesn't necessarily mean physical contact, but close proximity, large respiratory droplets that may just pass directly from one. That being said, the best strategies we can use are elimination of hazards. So if we can keep people apart, infected individuals can't spread the virus. Looking down this list here, engineering controls, which is what we're going to focus on, is in the middle of the group here. We think it has significant impact, but it's not the most effective means for controlling viral spread. One other key note I'd like you to keep in mind throughout the entire discussion today is that our focus is to mitigate viral transmission. With what we're talking about using buildings, we don't have any way to ensure that we could eliminate transmission. So one more piece of information that is specific to K-12 schools. The Government Accountability Office issued a report in June that talks about school systems and deficiencies specifically in school systems. So what that study highlights is that many schools have systems that either don't operate or they might just not have the systems at all, right? I would guess many or most of you have experienced school buildings that still don't have a ventilation system. They're heated, not cooled. It's difficult to address some of the things we're talking about with that type of system. So, all of that information is good to keep in mind as background as we talk through the rest of this presentation. I also want to be clear that there are a lot of things that we don't know. And so those all come into play. There is significant information in the media that, and in studies, in fact, not just the media, but that children may not shed virus or have as many viral particles. That may be true. They may not be as good at transmitting it. There are also studies that suggest they're as good or better. So we want to keep that in mind. We don't know what the viral shedding rate is, and we also don't know what it is for different activities. We know that some activities appear to have higher rates, which makes sense with an airborne virus. Breathing, speaking, singing, shouting, coughing, sneezing. So we don't know what the infectious dose is for the virus. So we don't know, and we don't know what that infectious dose means for the severity of the infection coming out of the severity of infection come out of infectious dose. So we don't know what the percentage of cases are from each transmission pathway, meaning whether it's airborne, surface. We don't know where the virus goes when it's airborne. I'll try to talk about that a little bit more. I did not include a study that has in the presentation, but there was a study done in Oregon at a hospital facility where they found viral RNA, and they have made no statements about the potential effectiveness of that RNA to infect someone, but it has been found in mechanical systems actually downstream of final filters. And then lastly, we don't know what the best air distribution strategies are for spaces, for occupied spaces, and it may vary for different space types. But discussion going on around that right now. So I'm going to focus for a few minutes on the schools team, the work that has been done, and I'll talk a little bit about the membership of the schools team first. So again, I'd like to acknowledge Rick Hermans for leading the group through getting the first and most of the second version that is put together. Dennis Knight has been very active on the schools team as well, and as I mentioned, he's the vice chair for the Epidemic Task Force.
Sorry, it seems your microphone.
I'll let you read the list, but two other names I want to mention briefly: Raj Sethi and Keith Hamelman. Keith and I did a presentation back in mid-June to a fairly large group around the country on school reopening focus. The other thing I'd point out just briefly is that we have folks from not only all over the US, but the United Kingdom and Canada as well in our group. So we're fortunate to have a lot of people contributing and really helping us move forward. So the information that I'm going to present in general is focused on the following assumptions. I want to be clear that they're not valid. I've already told you some of them aren't valid, but I think that for our discussion and for this understanding, I'm clear about a baseline that we're hoping. So this one is a valid assumption. I think always occupant health and safety is our focus. Energy efficiency is important. Many of us focus on it on a day-to-day basis under normal circumstances, but right now, social distancing and PPE used to the extent possible and meeting the requirements of cognizant authorities is critical. We recommend using it in accordance with all of the recommendations from those cognizant authorities. Proper cleaning protocols should be used. We're making the assumption that they are. This one we know is not a valid assumption all the time, but for the sake of our focus right now, we're assuming that buildings have, and also hoping and assuming that we've got means for control modifications. So we're hoping and the ability to make changes to that control system. So the schools team has worked diligently for a number of months now, starting in, I believe it was early April. We had our first document posted in early May, and an updated document was posted in mid-July. That document goes through, it has a number of sections in it, including some checklists, information on different strategies, and we'll talk through what I think are the highlights of those today. We are continuing to work and fully expect to be issuing more updates. So as I mentioned earlier, ASHRAE normally moves at a certain speed. ASHRAE documents being issued, things get reviewed in a meaningful and careful way when they are issued by the society. Given the urgency that we're dealing with here, much like the research that's being published, we didn't have time to go through the number of iterations of review that we normally have or would have. So I I will say things in this document that we are working to improve upon and will continue to do. And there's new information coming out that may change some of these recommendations. So I just want to be clear about that. Key concepts in that document. So one of the big things that you'll see as you go through it is that we want to ensure that building systems operate the way they were designed and the way they were intended. Because we know that there are many buildings out there that over time have drifted away from those initial set points or configurations. There are outside air dampers that are not open. There are CO2 sensors that have skewed significantly from calibration. There are many things that have changed. So with that in mind, we want to look at trending with controls where possible, testing and balancing, reviewing how air is distributed to spaces, whether we're getting good air mixing. Though it's not explicitly stated, if you read the recommendations, essentially one of the ideas that could be utilized is retrocommissioning for facilities. It is not specifically stated in the current version. I think it will be in a future version, but we would certainly recommend calibration of critical sensors, particularly those that might not stay in calibration as well as others. Looking for IAQ trouble spots. We don't have any, at least I'm not aware of any specific information on potential compounding effects that could happen if you have indoor air quality issues and someone that enters with a virus that could be attacking their lungs, but certainly we don't want to create the potential for more trouble there. So, and then the last item here, if we have time towards the end, I will talk about it in a little more detail, but energy recovery devices, this is something there's been a fair amount of discussion on. And again, TC 5.5, I believe it is, put together a good document for reference on. So we want to make sure the systems work to the extent possible as they were intended. If it's feasible, we also want to go back and validate our designs. We want to make sure that we've got code required ventilation. So I'm going to make the assumption here that that's generally based on some version of ASHRAE 62.1. There is a lot of discussion that can be had about older buildings and may not meet our current ventilation codes. In some cases, it may exceed it. So we want to look at that though and understand where these buildings stand in comparison to what we would hope to see today. We want to make sure that systems are capable of maintaining acceptable indoor conditions, and then get a good understanding of what the system capacities are, and that'll come into play in a few minutes as we talk about some of the strategies we might look to incorporate. So we've got in the document some short-term system modifications and improvements, and then some potentially longer-term. So from a short-term perspective, one of the things we want to do is look at increasing ventilation if we can. We can dilute the air in the classrooms, no different than any other contaminant. Outdoor air should help us remove contaminants from the building. We want to increase filter efficiency where possible. So we're going to focus on the MERV rating. I'll talk about a few other potential ratings that could be considered as well. But we want to do our best to improve filter efficiency so that if we can't get the viral particles out of the space through dilution with outdoor air, we've got another avenue to help us, I guess, reduce that concentration by removing them with filtration. There are likely minor modifications to control sequences that we want to consider. So, and we'll talk a little more about it, but building flushing prior to and after occupancy, looking at potential changes to demand controlled ventilation. We'll also talk about that in a little more detail. And then other possible improvements to the space. I put improvements in quotes there just to make sure that we understand that all of these things need to be carefully considered. Anything that we look at doing could have very positive benefits to a space or a very negative impact if it's not applied correctly. So terminal filtration units in a space, humidification, there are some other strategies we'll discuss as well. So possible future building changes could include design to have additional outdoor air capabilities. It could include design for increased filtration levels beyond what's normally recommended today. We may have new recommendations for air distribution in spaces. We may design with additional capacity throughout. Those are all, those are all thoughts about things that could happen. There are likely challenges that go with all of those. If we oversize, we run into issues with turn down. As we increase filtration effectiveness, we also generally increase pressure drops. So we're talking about additional energy use. All of these things will be discussed, I think, for significant, in a meaningful and significant way moving forward. And in the document, you will see two checklists. There is a checklist number 1 called Summer Checklist for Fall Starter Classes. The intent for this checklist was to serve as a checklist for an unoccupied period. So it's got a number of things in it. Some of those things we've probably passed the point where they're realistically valid. So focusing on deferred maintenance and potentially other work that needs to happen in a building that might not normally have significant periods where it's unoccupied. That was more relevant probably in early May than it might be today, but just for reference, those are still in the document. Looking at just high level, does the system work? What might we need to do? And then doing some detailed analysis if it makes sense. Checklist number 2 is really more focused on getting the systems up and running, making sure that they're operating correctly from a day-to-day basis, putting in place means to make sure that the systems continue to operate correctly, and that we are doing everything we can to ensure that we're getting that, maintaining good indoor air or indoor environmental control. Just getting the building to work as well as it can, given all of the considerations that we're going to talk through. So with that in mind, we'll talk through a few of the detailed strategies that are in here. I guess just real quick, I had mentioned to Adam before we started, do we want to, I don't know if we've got many questions in yet, if we want to do any questions, or if I should just keep moving. I want to make sure through. I'll just keep going. So the detailed strategies to keep in mind here, as I mentioned earlier, we're going to assume that we're using ASHRAE 62.1 as kind of our baseline for ventilation. So for reference, code is our minimum. It's not, that doesn't mean we can't go above it. I want to keep that. So, our justification for why we want to look at additional ventilation. So this is something that Rick Herman's put together as a theoretical analysis. This is based on the Wells-Riley equation, which we could get into a little more. It's a fairly, it's been around for a while, but it's been used significantly for airborne infection transmission. So quickly, this calculation uses a unitless term called a quanta, and then looks at a number of other factors. So there are some assumptions that are put in here, but the key takeaway from this graph to look at is based on the predictions from the Wells-Riley equation, there is significant reduction in potential for airborne transmission with higher air change rates of clean air in a space. And so clean air could be filtered air, could be outdoor air. There's more to that, but I don't know that we'll have time to get into it today. So just wanted to give that for background. We have in our guidance a recommendation for flushing the building and operating mechanical systems for 1 week. That's different than what you'll see in the building readiness documents or some of the other guidance. Our intent in putting that in there is not necessarily just to remove contaminants, because the reality is the contaminants should be removed in a number of hours of operating the system if it's got the right ventilation rates. Our intent is to look at buildings that likely have had systems shut off over the summer and may have moisture content. So we want to get humidity out of the building. We want to get temperature under control. That may not be something that can be done in a one-day period. So it could vary significantly from school district to school district, climate zone. If you're in northern Minnesota versus Missouri, that there may be differences in how much how much flushing needs to happen, and whether or not systems were run at some extent over the summer. On a daily basis, we expect to operate a pre and post occupancy flush and focus on operating the systems with either occupied or peak ventilation rates. So the focus of this flush is specifically to remove contaminants from the space. If you look at our guidance, you're going to see a recommendation for 2 hours of operation. That 2 hours is also referenced in the building readiness document. However, they have a note and in their document that identifies a real focus of getting 3 air changes of outdoor air. That is expected to reduce the contaminant quantity in a space by, I believe I should say that is, by 95% or more. So it's likely that many code compliant buildings, especially K-12 facilities, may need less than 2 hours. If you look at a typical classroom, you may be getting 2.5 to 3.5 air changes per hour of outdoor air running at occupied ventilation rate. So this is one that certainly most buildings don't do today. There are probably control sequence requirements that come into play because we not only likely have to change schedule, but if there's demand controlled ventilation or other strategies in place, those will need to be modified. As we'll discuss in a number of other cases, system capabilities need to be reviewed. We need to make sure we don't overdo it with so the next strategy under ventilation and flushing would be to look at increasing ventilation. So as I mentioned before, the more outdoor air we can get into the space, the more likely we are to be able to dilute contaminants in that space. Our guidance suggests increasing outdoor airflow rates to as high as 100% if possible. We understand that that's not likely in many cases, but it's at least worthy of consideration. We'll talk in more detail about system capacities on a future slide, but that's a critical item. Coils were designed with a certain amount of outside air in place. There may be control strategies that make sense to consider, and we'll talk about that. We want to make sure that in increasing our outside air, we don't negatively impact high humidity and potentially generate condensation, mold, something like that in the building. Our guidance also recommends disabling demand controlled ventilation. There are some key takeaways from that. Doing so should ensure that all spaces receive adequate ventilation for many system configurations, but there are some where we may actually create problems. We may over-ventilate unoccupied spaces. So we'll go through that in just a little more detail as well. So from a capacity standpoint, and this is for Des Moines, assuming not that this is necessarily your design point, but just for rough information, 2% enthalpy cooling design point from 2017 ASHRAE weather data. And assuming that we're, again, rules of thumb here, not trying to get into a specific design, but if we're going for 55 degree saturated supply air coming off your coil, and you've got 75 degree, 50% relative humidity return air, if you look at the difference between 20% outside air, hopefully you can see my cursor here, 20% outside air, 50% outside air, or 80% outside air, you're going to see an increase in your cooling load of as much as 95% if you go from 20% to 80%. The bigger takeaway in my mind is the difference in the sensible heat ratio at that coil. Depending on what type of system you're using, it's likely that many coils are going to operate best in that 70+% sensible heat ratio range. When you get to 80% outside air, you're below 50%. So we may run into, you may be able to do this and maintain dry bulb discharge temperatures in some cases, although it's likely that you won't. But I would be very cautious about doing this from a latent load perspective or dehumidification perspective, unless you're certain that your coil can do it. Demand-controlled ventilation is another strategy that, again, as stated previously, I think is a very good idea to disable it or adjust how it controls. That being said, if you have a system that's designed with diversity in place, so if you've got a dedicated outside air system that serves individual classrooms and has less capacity than the sum of all the connected load, disabling demand-controlled ventilation is likely not a good strategy because there is a high probability that you will, if all of your terminals open at once, you're going to feed the ones that are closest to the unit, and you may end up short ventilation airflow at occupied spaces if they happen to be the most hydraulically remote on the duct system. So the next strategy to talk about in detail is filtration. Our goal with filtration is to capture viral particles. So assuming that most of you are aware, but just briefly, we use, for most cases today, minimum efficiency reporting value, or MERV standard, from ASHRAE standard 52.2 for rating filters. My guess is that most educational facilities, if we're talking central or potentially terminal devices, but central air handlers, are currently operating with filters that are in this range of 6 to 8 MERV rating. Our recommended guidance, not just in the schools document, but for all of the epidemic task force information that's out there, and there is great information from the filtration and disinfection team for reference, is to get to a MERV 13 rating, and we would prefer to get to a MERV 14 rating if that's feasible. Now, the challenges with that are going to be discussed in a minute, but obviously we're talking about significantly higher pressure drop if you're looking at a mechanical filter here. One other note, there are a few other standards to keep in mind. There is a MERV A standard that we'll talk about in just a minute. ISO has a few standards, one for normal filtration and then one for higher levels of filtration, including HEPA. And I'll apologize if you can hear a dog barking upstairs. So, as I mentioned, we're targeting MERV 13. MERV 14 is preferred if we can do it, but there are a number of considerations we need to look at. So that is a generic statement. Not all units make sense to improve filtration on. If you have a dedicated outside air unit that's pulling in strictly outside air, it's likely that additional filtration may not be warranted, and that it may be additional cost, both from a filtration perspective, purchasing the filters, and an energy perspective that doesn't reap any benefit. You need to look at filter racks in your existing equipment and understand the configuration, condition, what size of filters they will accommodate. There are some units that won't be able to handle a larger filter. The racks may not be in good shape. There might be leakage around them, and putting in a MERV 13 or MERV 14 filter may just encourage more leakage around the filters, and maybe, if not have no impact, may even be counterproductive. So we need to consider that. The pressure drop that's added, we need to look at our fans, and we'll look at a fan curve in just a minute, but the focus is making sure we don't reduce capacity. We need to look at what the filter type is. So whether it's mechanical, there are many filters that are use an electrostatic charge that are rated into the MERV 13, 14 range, that can be put into a 1 or 2 inch filter rack, and they may be a great option depending on what you're doing and how your systems work, but consideration needs to be given to those things. And then finally, we need to look at what type of equipment are you putting it in. Is it a central air handler or is it a terminal device? If it's a fan coil, a cabinet unit heater, a unit ventilator, a VRF fan coil, any of those things may not have the capacity to handle any additional pressure drop, you may not be able to find higher MERV rated filters in those size ranges. So again, consideration needs to be given to that. One thing that I just want to go through briefly related to filtration is the idea that filters are a linear, have linear performance. I've heard this a number of times recently, and I want to make sure it's clear that that is not the case. So this comes from a study by Kowalski and Bonfleth, that's Bill Bonfleth, whose name you've already heard a few times, from 2002. So the approximate size of, if we were just looking at a SARS-CoV-2 viral particle floating in the air, would be represented by that line. The reality is those viral particles are expelled generally as some sort of respiratory droplet. So it's likely that the size is larger than what this line indicates, but this looks to be generally a worst case option. So I'm using it as our reference point. If you have a MERV 8 filter, your fractional efficiency at that size is going to be 10%. You go to a MERV 13, we jump up to somewhere closer to 40%. And in a MERV 14, we're in the range of 60%. Now, again, this is likely a worst case if you move up to a 2 or 3 micron particle, which may be where these particles are coming out as respiratory droplets. The addition of higher filtration could result in problems for fans. If we add a ½ an inch or more of static pressure to a fan system, that could be a problem. This is just a quick selection to show a case where a fan may not have been selected with much extra capacity. In adding additional filtration to this device, you may see a significant reduction in airflow, and it depends. Fans need to be looked at, curves need to be considered. We need to check how the fan actually performs. Is it performing on its curve or not? So those are all considerations to look at. The key takeaway, though, is if it comes down to a significant reduction in airflow or additional filtration at this point, it's likely that the airflow is more important than the filtration to maintain good air mixing in space, to get those particles out with ventilation, and to get some capture at the filtration. So as I mentioned before, there are different ratings for filters. There's MERV A, which essentially disables the electrostatic charge on a filter and gives you a rating for that mechanical perspective. And then there are ISO ratings. So it's worthwhile to get an understanding of those and to look at what you can accommodate. I would be an advocate, and this is my personal recommendation, for getting a mechanical filter. If you can do a straight MERV rated filter, mechanical operation to get to 13 or 14, that's a best case. If you can't, there may be some consideration to going down to a MERV 11 filter if you can get that to work. If not, I would definitely still consider going to a MERV A filter. There may be more frequent replacements required given the electrostatic charge can wear off, but it's likely better than having a standard MERV 7 filter in place. We don't expect HEPA filtration to be put in place for school facilities in general. I'm going to try to hurry through things a little bit more. I've been talking probably more than I should. Quickly, terminal equipment, I've already mentioned. We've got to look and see what sizes of filters are available, or what types of filters are available for the sizes that are required. How frequent? How is the system configured? If you cannot get to a point where you can get improved filtration for a space, that becomes a good time to consider whether or not portable HEPA units should be looked at in the space. There are a few notes on that. We want to make sure if you put a portable HEPA unit in the space that it doesn't interfere with space airflow. You want to consider where the air comes into and out of the unit so that we're not I guess that we're optimizing the use of the unit in space. You want to look at what that unit's rated for air per hour. We recommend getting 2 if possible. That may be a challenge. And then the last one, and I think this is a key one for school facilities, classrooms in particular, is the sound that's generated by that device, because if a teacher turns it off, it doesn't do any good. So these units can get quite loud when they're turned up to their full speed. So that's something that needs to be looked at. Okay, humidification. I'll go through this as quickly as I can. There is a significant reduction in viral transmission from some studies based on influenza A when we bring humidity levels up to 40% or greater. So if we're in the Midwest in the summer and the cooling season, keeping 40% as a minimum probably isn't a challenge. This really comes into play during the heating season. So I would make a few editorial notes on this. I do not believe that there's any consideration in this study given to face coverings, social distancing, other factors. So this is strictly looking at, to my knowledge at least, the impact of humidification on airborne viral transmission. So there can be significant benefits. If you've got a facility that can accommodate that, it may make sense. So you can look at adding humidification to your central air handling equipment. You can look at portable humidifiers being placed into individual classrooms or other occupied spaces. We want to make sure that water treatment is considered very carefully, because I have walked into mechanical room after mechanical room and seen humidifiers that have been disabled and not used for years because the water wasn't treated properly. We also want to make sure that that water isn't introducing any contaminants in the space that could be, again, compounded. Treated, are we making sure we don't worsen the indoor air quality in the space? The next one, and we'll get into this a little more here, is the potential for condensation. But for many of us that are, if most of the viewers are in Region 6, so Upper Midwest, the potential exists throughout a good portion of the winter to have condensation in your building envelope. So key thing here is, if you look at these points on the psych chart, we've got 70 degrees and 20% relative humidity down at the bottom here. And that is shown with this line. If you jump up to 70 and 40, our dew point jumps from 27.7 to 44.6. If we go to 60%, it's at 55.5. So thinking about that moving through your wall, if indoor air comes into contact with surfaces below the dew point temperature, you will get condensation. This is just obviously a sample wall, but in an older facility, you may not have much insulation. There may be significant opportunity for problems. So something to very carefully consider if humidification. The last strategies that I want to talk about briefly are other means for air treatment. So there are a lot of options out there right now. Many statements are being made about those options. I'm not an expert on any of them, and am not here to necessarily make endorsements for any one or not. Of those technologies, they generally aim to deactivate viral particles. There are some that will cause particles to agglomerate using a charge, and then maybe get caught more effectively by a filter, or fall out of suspension in the air, drop to a surface. The thing that I would recommend with any of these, so some of them have been studied for years and likely do have merit in consideration, whether it be for the pandemic to address airborne viral particles, or for other strategies such as coil cleaning. Others do not have as much research. There are certainly some manufacturers that make claims that appear fantastic. Others, I think, have really good information. I would look carefully for independent testing. I would look for the standards that devices are rated to, and you also want to be very careful with any of these strategies that you consider whether or not they generate ozone. We don't want to add other contaminants of concern to the space. So one other item that I would note, that some of the strategies that would fall into this category in the past have recommended reducing ventilation air. I certainly would not consider that at this time. It might be generally not a proponent of that, but definitely not today. So I've already mentioned some of the future changes that could be coming. It's possible that we'll see increased outdoor airflow rates. It's possible that we'll see different recommendations or standards for filtration. It's possible that we'll see recommendations for excess capacity being baked into our designs. We may see changes to recommendations for air distribution in occupied spaces. I've seen information suggesting that displacement's the right approach. I've seen information suggesting that high supply and low return is the right approach. There is a lot of information out there. There's CFD modeling that's happening for multiple space types. I don't know what the right answer is yet. I think our best approach at the moment is to stick with making sure we're getting good air distribution throughout the space and good mixing so we can capture those airborne particles. But that, I think, is likely to come. That guidance is likely to come. Humidification, again, could it be something that we put into air treatment or cleaning technologies? So the other options we just talked about, whatever they might be, could be something that becomes a recommendation. So I expect to see more standards and testing for those devices so that claims can be based on common information moving forward. So in summary, there are a lot of variables that we're dealing with. Many of them are out of our control, but there are things that we can do. Information is changing rapidly. We don't have all the information, and we know that some of it will be developed here over the next few months as schools go back into session. Airborne transmission is definitely possible. Systems need to work as intended. The use of ventilation and filtration properly can reduce viral particle concentration, which then can reduce the potential for airborne transmission. We need to consider all of the applications for whatever strategy we're looking to implement. And we know that we've got changes coming. So with that, I've run a little longer than I hoped, but I would be happy to try to respond to some questions.
Thank you, Corey. We have some questions come in. I think I've passed them all along to you. There seems to be a couple more.
I'm having a little trouble hearing. I'm going to see if I can get out of this real quick and turn on my volume, maybe.
Can you hear us?
Yeah, sorry about that.
Okay, no worries. I forwarded all the questions over to you if you just want to read them. Otherwise, I can read them. You can answer whatever's your preference.
Perfect. I apologize. I did not see the sound issue. So I hope it wasn't too distracting. Okay. So there's a question about window air conditioner filtration. We've had a number of questions come into the group, to the Epidemic Task Force on that. In general, I don't think you're going to get any meaningful filtration from a window air conditioner. We've recommended, rather than, I guess, my recommendation in general is not to occupy spaces that don't have ventilation. That being said, I know that some of them will be occupied. So in those cases, we've recommended using operable windows if they're available, or looking at portable HEPA filtration units being located in the classrooms or other occupied spaces. Hopefully that helps. There's a note about not opening fire doors for ventilation. That's a good comment. There's a question about, is there consideration to review DV effectiveness with the same method as the air change ratio? I'm not sure. Is that, I'm not sure if that's intended to be demand controlled ventilation. Just briefly, with demand controlled ventilation, there are some suggested control strategies that might involve, and actually this wouldn't have to be demand controlled ventilation, it could be ventilation in general, to essentially do an inversion of your economizer mode operation and basically let your coil run all out all the time and put as much and modulate your outside air to improve the amount of outside air you can get in the space without negatively impacting the system operation. Hopefully that's a response to that one. There's a comment about the path of ventilation air in the space, and there's basically, I think there are a number of questions. I guess this one's asking about or commenting about airflow moving across the space, capturing particles, and I think both potentially taking them out of the space, but also one of the concerns is bringing them across the breathing zone of other space occupants. There's a lot of work going into that right now. I don't think we've got good enough information to make any recommendations on changing that. There's a question on how MER 13 or 14 compares to HEPA. So I didn't have the graph, but essentially where you see the HEPA graph, if we go back, can you see my screen still, Adam? So the HEPA graph essentially looks almost flat on here. They've got a exaggerated or a version that zooms in to this 0.2, 0.3 micron range, which is where the lowest capture efficiency is on HEPA at that 99.97% range. So it would look almost like a flat line at the top of this graph for reference. There's a great comment in here about the hazards of changing filters with COVID, and I should have made that as a comment. For school districts, this is important. So in our guidance, there is recommendation about PPE, appropriate PPE for filter changes, because there's certainly potential that viral particles are present on filters. So we want to make sure we've got we're taking care of the staff members that are working with that. There's a question about separate filtration units, perhaps freestanding or ceiling mounted. I have talked to a few folks about doing so. We certainly have recommended the portable freestanding units in a number of cases. We've also talked about looking at the fan filter units that would just return from the space, push air through a HEPA filter and back into the space. There's potential for significant capture of viral particles that way. Again, distribution in the space should be considered. We increase ventilation airflow that increases load. Would energy recovery not be an option to lower load impacts if exhaust air transfer ratio is near zero? Yeah, certainly I would. So I didn't get into it, but there was initially some recommendation from our group and others to disable or seriously consider disabling energy recovery devices. I think that needs to be carefully thought through before doing so. I would recommend not necessarily disabling them, but looking at leakage and making sure that's kept to a minimum. The reality is you're bringing in outside air, which is going to help reduce concentrations in the building. But as I mentioned, the TC 5.5 put together a document that should be available on the Epidemic Task Force website that has a lot of really good information there. There's a question about bipolar ionization and effectiveness in mitigating COVID. So that's a really good question. That's one that there are claims being made, and some of those claims may be valid. I can't provide a confident response that they're all valid. So I'd be very careful with them. That is something that I would look at closely before implementing. There's a question about UV mounted in the space, so I'm assuming that would be the upper air UV approach. That certainly could be a good strategy depending on the situation. I would look at that closely. Sorry about the audio issues. I'm not sure what might be going on there. How does humidification reduce COVID transmission? I think, okay. So the question is why, why is it doing that? So the speculation from the studies is that by having humidification, we don't have those viral particles. They're in respiratory droplets. If those droplets are large enough, they drop to the floor. In very dry air in the winter, in particular the heating season, those droplets may evaporate fairly quickly, leaving behind the viral particles to float around in a much smaller or lighter condition that can remain airborne for a significant period of time. There's a question about filtration level being reduced if an ionization system is used. I know that there are claims about performance related to that. Again, I would check the basis of those claims carefully. Just make sure that the information you're getting is accurate and from an independent testing laboratory. A question about how heat pump units are affected. Any terminal equipment, fan coil units, heat pumps, others, there are challenges with circulation and filtration. So if outdoor air is being provided to them appropriately, they may be very reasonable. If it's not, it could be a challenge. Adam, I think I'm a few minutes over here. I'm happy to keep going, but certainly don't want to.
It looks like we still have quite a few attendees, so.
Okay. I'll try to get through a few more, and again, apologize for the audio issues. I'm sorry for that. Another question about electronic air cleaning technologies or bipolar ionization. So we've gotten a lot of questions about bipolar ionization, and what I will say is that there are claims being made by multiple manufacturers. Some of them I believe are likely true. Others I have significant concerns with. Bipolar ionization in the past has had significant issues with ozone generation. I would not advocate for or against, in general, bipolar ionization being applied. I would just, again, caution you to look very closely at any studies or independent testing that's been done, and try to make sure that all has occurred at the same operating conditions. So there's a question about portable filtration besides HEPA that's not so noisy. I think there may be some that are a little quieter than others. If it's feasible, I think those fan filter units may be the best option from a sound perspective, but the cost, lead time, and effort to get them installed is likely a significant hurdle to implementation. Another question on bipolar ionization, I think. Oh, thanks for the clarification on the, the question before was not related to command control. There was a slide that showed an instant of infection compared to the air change rate. Yeah, so that was based on the Riley-Wells equation. I'm sorry, Wells-Riley equation. And that's really a theoretical analysis. I wouldn't use that as a final source for anything, but it's good to have as a reference point, I think. And I'm not sure that I've fully answered that, so please don't hesitate to reach out if you want to go through that in more detail. Ventilating and opening classroom windows is a good question. So I think that's something to be considered carefully. If it's in a building that doesn't have ventilation that's going to be occupied, again, I'm not recommending that, but if it's going to be occupied, if there are operable windows, I would recommend opening them and potentially placing some fans at opposite ends of the room, one pulling in, one pulling out. At least you get good air movement through the space and you get ventilation air. If you're talking about a facility that's got a mechanical system that's operating, I would have significant concerns about control of temperature and humidity in the space and the potential for those, if you have high humidity or other issues that are generated by doing that, the potential that makes conditions in the space worse. So there's a question about facilities that are geothermal and only change out air when the CO2 level gets too high. So that's a really good question. What we're recommending at this point, and it depends very significantly on configuration again of the system, but would generally recommend adjusting the set point if the system has capacity to serve all the occupied spaces at the same time. So if it doesn't have diversity factored in, you can adjust your CO2 set point down. You can adjust it as far down as to 400 or 450 parts per million, which would essentially just take you to ambient. So it's going to force the system to run outside air through at full or peak rate all the time. Now, if your system has diversity designed into it and can't handle all the occupied spaces at the same time, I would still not discourage you from looking at potentially lowering set points if they're above 1,000 or so parts per million, but would probably consider, I think there are a number of options that could be considered. You could look at that inverse control strategy for economizer, depending on system configuration. But if you're talking a dedicated outside air unit that's got a maximum airflow, you really want to make sure you're tracking your occupants around the building. So sorry for the somewhat vague response there. That's the challenge that we're dealing with on a lot of these things is it really depends on individual configurations, if that makes sense. There's a question about ozone. I think it is likely. I don't know that I have any definitive information that states that it kills the virus, but I think it's likely ozone generally is pretty good at killing things. But our concern with it in an occupied building is that it's also bad for occupants. So if we're putting something in the space that that could create irritation or issues that might cause breathing difficulty for occupants, there's a potential challenge there. So it could, I know that it's being used some places, but our recommendations at this point would be to not generate ozone if possible. I think, and I'm sure I have skipped some questions, but I think that brings us to the bottom of the list. So I'd gladly take any more or go through anything else, but I really appreciate everyone's time. I hope this was useful and informative, and I'm sorry for the audio issues.
I think that wraps up the questions that we've seen. the Iowa chapter is going to review the recording, make sure that we can have some good audio for it. But either way, we'll share with all attendees. So, Corey, about getting slides, I think that's more a question for you than for me.
Yeah, I've got a couple of folks that allowed me to use their information. I'll need to make sure they're okay with that. But I will check on that today, and hopefully we can get those shared. And if there's anything I need to take out, I'll just take out those individual items.
Okay, so if you'd like slides for this, please just use Corey's contact information and get in touch with him. And then at the Iowa chapter, we'll make slides available when we get that information from Corey. So thank you very much, everybody. Enjoy the rest of your day.
Thank you.